Alright, so let's start a new chapter, chapter 16, which is on hypothesis testing for the mean. How it starts, we're going to go back to that situation when you have a general population. It's about the IQ. We have the mean and the standard deviation. Now, there's a supposition, an assumption. So we're going to suppose that in general, Year 12 mathematics students score higher on IQ tests than member of the general population. So to investigate, we select a random sample of 100 Year 12 math students, and we find out that the sample mean IQ is 103.6, which is 3.6 higher than the mean IQ of people in general. Sorry, I'm just checking. I'm not in a way. So, all right. Now, two ways coming out of it. Is it reasonable to conclude that Year 12 math students score higher on IQ tests than the general public? We already know that the sample means will vary from sample to sample, and we would not expect the mean of an individual sample to have exactly the same value as the mean of the population from which it is drawn, which is 100. Okay? So you have two possibilities. The one that will be more general. So let's say we have one explanation is that the students perform no better on the IQ test than the population, and that difference that we get is due to the sample that's been selected. The other possibilities or explanation is actually that students are doing better on IQ test than the population, and that sample mean confirms that explanation. So with the hypothesis testing, we're gonna come up with two explanations, and from the data, by doing measurements and analysis, then based on probability, we're gonna see which explanation is going to be more likely. Alright, let's go to the concept. So the idea is, let's imagine it's a trial. You're in court. We are on the prosecutor side, and we need to prove that a person is guilty. But, so that's why it says, however, the starting point of the court case is we have to assume the person is innocent, and as we provide more evidence, we're gonna show that that statement is untenable. So it's gonna lead towards the person to be not innocent, which is towards guilty. All right. So the assumption of innocence, which is what we want to disprove, is what we call the null hypothesis. So it's what we call H0. Then we collect evidence, data, to prove that H0, that null hypothesis is untenable, and then we can conclude that there is support for a research hypothesis, and that other hypothesis is what we call the alternative hypothesis, or H1. Okay? So the original statement is you have an hypothesis that you want to that's what you want to go towards to. So you're going to create a null hypothesis, which is the opposite. You're going to disprove it with data, and we're going to lean back towards our original hypothesis. It's not going to be perfect, but at least we should be able to disprove the opposite. Alright, so to reiterate what's been done before with the hypothesis. So in the IQ example, we have a population, and we have a statement about the Year 12 math students perform better than the general population. So with the hypothesis test, we're going to start to assume the opposite. So we're going to assume the Year 12 math students perform no better, or actually the same as the general population. The general population has a mean of 100 and the standard deviation is 15. So with the null hypothesis, we assume the Year 12s are doing the same as the general population. H0 is mu equal 100. So it's the same as the general population. Which is, to summarize, so we have H0. The sample that we draw will have the same mean as before. Now the alternative hypothesis, even if you have a sample variability, we're going to ignore that. The amount of variation is so much, we're going to be so much away, that it's very likely that the sample has been drawn from a population with a mean will not be the same as the original population. So with the IQ example, if we H1 will be Year 12 math students will have a mean that will be different from the general population, and in that situation we can narrow it down to being higher. Alright, first example. So you have a statement. The average fuel consumption from a particular model is 13.7 liters per 100 kilometers. Now the manufacturer is claiming, so that's a claim, that the new model is using less. We take a sample of size 25 and they have an average fuel consumption of 12.5, which is less. Alright, now you need to write the null and alternative hypothesis. So this statement, the claim is using less than that. So we have to do the opposite for the null hypothesis. Knowing that the mean is 13.7, we're going to say that for the null hypothesis, the sample mean is the same. So it's going to be the same as the population mean. With the alternative hypothesis, which is what we want to lean towards to, we're going to say that the sample mean is actually lower than the population mean. So our sample mean is going to be lower than the population mean, which is the 13.7. We're not using the 12.5 yet. Later on, when we do some further calculation, that's when we're going to be using that value. So that's pretty much what we've done. Alright, we're going to do some statistics on the test. That's going to be 3 parts. First is the p-value. We're going to look at how the evidence is strong and what it means in terms of statistics. Okay, the p-value, so it's an arbitrary amount that is a probability of observing a value of the sample statistics as extreme as or more extreme than the one observed, assuming that the null hypothesis is true. Here is a little bit of what we've done before with the distribution of a sample mean that would lean towards a normal distribution, so we get the expected value and a standard deviation. Now with the p-value, let's see how we actually determine that p-value. Okay, so from the first part of the example with the fuel consumption, we have our null hypothesis and we have the alternative hypothesis. Okay, Uh, Now we have some information about the normal distribution. So we have our sigma, we have the mean, which is the same, but we have our standard deviation, and now we have our sample. Okay, so from that sample, what we do is, using the sample size, we're going to determine the standard deviation of that sample mean, because as it is normally distributed. The expected value is what we had from the population mean. From that, with the p-value, is the definition of the p-value is the sample mean is, we calculate the probability that the sample mean is less than the 12.5 from the sample, knowing that the population mean is 13.7. So that's coming from a standardized formula. We apply that. I'll show you how to calculate it on the CAS calculator, and we get that amount. Okay, at the moment there's no interpretation, but that's just calculating the p-value. Alright, using a CAS calculator, you can do that using a statistics stat test and the z-test function. You enter those parameters: population mean, the standard standard deviation of the population. Let me go back. Yep. Then we need the information of the sample mean. So we have the sample mean and the sample size, and we need to specify the type of alternate hypothesis. So the alternate hypothesis is less than the 13.7, and here we can read out the p-value. Okay, so that's how you just calculate the p-value. Now the interpretation of that: if your p-value is very small, so less than 0.1%, it's a very strong evidence against the null hypothesis. It means that you're going to lead towards H1, and H1 in the fuel consumption, it means that it's not the same as the average fuel consumption, but it's actually going to be towards the alternative, which is less fuel consumption. So ideally you want a very small p-value, and as your p-value increases, you are starting to have less evidence against the null hypothesis. So again, the analogy of court is, you're the prosecutor, you're charging somebody that is you want it to be guilty, but you're gonna have to start with the assumption that the person is innocent. So you have an H0 is you claiming that the person is innocent, but as you're gathering a lot of evidence, you're actually getting more evidence against the person's innocence, and you're leading towards a guilty verdict. If you do not have enough evidence, your p-value is going to be much higher, and then you have insufficient evidence, and you're leading towards a mistrial. I hope that helps a bit. Okay. All right. So using the same example as before, we calculate the p-value. How do we interpret the p-value? So we read the p-value, which is down here. Then we can say we have a it's more than 1%, so it's between 1 and 5%, so it's under the good evidence. So we can interpret this p-value as a good evidence against the null hypothesis and in support of the hypothesis that the fuel consumption of the new model is less than the previous model, which is the H1, the alternative hypothesis or the alternate hypothesis. Again, I think, sorry, let me move myself, I'm in the way. Alright, now those values have been kind of chosen arbitrarily. arbitrarily. So what we're going to introduce now is a statistical significance. So the it's an alpha value. It's called the significance level of a test, and it's what we call the condition for rejecting the null hypothesis. If that p-value is less than alpha, then we reject the null hypothesis. So we're moving from a from an innocence towards a guilty verdict. But if the p-value is greater than alpha, then we can't move away from the innocence statement. So it's like we don't know if the person is innocent or guilty. Okay. Ideally, you want to be in that first situation when the p-value is less than alpha. If it's more, anything goes. Z-test, it has to do with how you so it's the way we do that is the hypothesis test for the mean of a sample drawn from a normally distribution population with known standard deviation, and that's how you define a Z-test. Okay. All right, so let's look at that example. Just give me a sec. Okay, pause the video, read the text, and we're gonna move on in a second to answer those questions. Okay. So the first one is to write down the hypothesis. So the first one is to say that the mean battery life is 240. So it's the same. So that's your null hypothesis, and the alternative hypothesis is less than 240. Okay, so now we can determine the information coming from this sample mean. We use the same mean as the population. We find the sample using the size of the sample mean, the sample standard deviation. We can apply the p-value formula by standardizing, and we get that amount, 10.6%, which is pretty high. Now the alpha value is 5%. Therefore, as our p-value is greater than the significance level, we can't reject the null hypothesis. So it's not the same, but again, we do not have enough evidence to lean towards the alternative hypothesis either. Okay, so we kind of don't know really. And that's it for 16A. I hope that made a little bit of sense, and I'll see you next session.